Next problem in strings related data structures and algorithms is minimum window substring. This is also one of the interesting problem, and this problem also asked by most of the bigger companies. Let's see what is this problem. Minimum window substring. The problem is that given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, included in the window. If there is no such substring, return the empty string. Okay. So here basically you need to find the minimum substring in which the the t characters like ABC should be present. In this case, minimum substring could be maximum. I mean, you can find the ABC in entire substring, entire string, but minimum is like a that B, A, and C. Okay, in which actually ABC is present in any order, doesn't matter the order. So that you need to return. Okay, so yeah, this will have two kind of solutions. One will be as usual like a brute force. For example, let me take this string. Okay, so this will have a brute force solution. A brute force could be like uh, brute force solution could be like we can start from uh, two loops. I start from zero and j will be going from zero to the length. So in this case, you can find like one way. During this time, you can find a ad ado and adob and so on. You can keep go till all the characters combination, and each character you check the t actually abc is present or not, and you need to figure out like a minimum uh, length of the string where you can find the abc, and that length you can keep taking it. So when I equal to 1 and j will move from 1 to n. In this case, you will skip this word and remaining all the substrings you can form a substrings and check that ABC will be present or not. Okay, this will be taking like to find the all combinations of substring. It will take O of n square, and also we need to check this substring contains this particular T ABC or not. Again, this will also takes kind of O of n, n meaning the length of t. So this is actually m square, I can say. So the total time complexity could be O of m square n. This is actually like a this is the brute force time complexity. So coming to optimized solution will be um, optimized solution could be like let us take this string, for example. Okay, this just take this string. You can take t and just take it as a map. Okay, in a map with the frequency of this particular abcs. In this case, a equal to 1 and the map of b also 1 and so on. Once you get that, you start from the minimum the sliding window. Basically, you can take the each substrings from lengths and check it out that you can check it out that if the count of the frequency of the t characters present or not in the substring whatever you took. For example, ADOB something. If this is present, this count is present, the frequency of this frequency of these t characters and the same characters in this substring also, the same frequency is there, then we can calculate the minimum length at that uh, at that substring whatever we formed. For example, this is not happening, and also this frequency either increasing or decreasing, then what we need to skip the first string and then keep moving. In that case, what we will get? DOBC, DOBC, and so on. We'll keep doing this till we get the minimum length. Actually, we can keep increasing this particular substring if you won't find it the number of frequency in the t characters and the substring characters. Keep moving and keep skipping the first character once we found more than whatever we need to be have a frequency. So that is how actually we can keep moving and we will find the minimum substring. So this will be taking the O of n time complexity, and also there is a space complexity of O of n. Okay, let's come and solve the using brute force now, and then we'll improve the solution with optimized solution. So as you see the brute force thing, it will be like a m of m square n basically, right? Let us see now how we can solve this. So now, for example, if length of s equal to 0 or length of t equal to 0, you can return empty, right? So after that, we can take the t map actually, uh, make map of byte into this. We will use for to find the frequency of the t string map, t string. Okay, this is simple. We just need to iterate to the length of t and try to t map of t of I plus plus. So you will get you got the frequency now of the t characters. Now let us see. Let us take two variables now, like a, since we need a method, right? So we can take min start and minimum length. Length this could be 0 and max dot max in 32. So we will insulate these two things. Now let us start from the start will be 0 and start will be less than this will be length of yes, start plus plus. So now what we can do is we'll try to see the S map. We need to see the S frequency using this. Make this is also same as that map of byte and int. So this map actually we need to use to check the frequency of these characters. Actually, the substrings we already calculated this one. T map, and this S map actually will use the frequency of the characters within this particular substring. Actually, for all the substrings, whatever we split from now on. So here we'll take for end should be start, and end is less than, again we'll take through the end, and end plus plus. So till here actually we will get the all substrings whatever we is yeah, s map of s of end plus plus. So now what we need to do is we need to check if we need to contain all, we need to pass s map and t map. Okay, this function we will write now. If this is true, then if n minus start plus 1 is less than min length, then min start will be start, and min length should be like a end minus start plus 1. Okay, and yeah, we can break from here. Okay, now yeah, once we are done with this, then let us see after coming out of this one, if minimum length is not found anything, then it will be max int 32. In this case also we need to return the empty string. Otherwise we need to return substring of from min start to uh, with minimum length. Okay, so this is what we need to do, and let us write a um, function, helper function, that is func contain all, and this will take two parameters, that is s map and t map of type map of byte and int, and this will return boolean variable now. So here what we will do is we'll traverse any one. Let us take for key and value equal to range of t map, and if s map of key less than value, return false. Any key actually which is less than or equal to the t map value frequency, then you just return the false. If you are not find, if you find everything are equal, then you return the true. Okay, even greater also fine actually, right? So yeah, this is the brute force solution. It's let us run and see what happens. 10. Okay, minimum length. Mhm. Min length, which line number 30, line number 30. Let me run again and see what is the problem. Undefined min length 30 line number. Okay, let us see now. Oops. Okay, let us see how it goes now. Yeah, so this is the brute force solution, and we are able to. We can't run this because if you run this, submit this, there will be a time limit. Some large string test cases will be failing. This is actually m square and time complexity. Okay. Uh, yeah, this will be like this is O of n, and this is also O of n, and this will be kind of O of combination, right? We need to iterate through the number of characters, actually t, size of t. So it is also like a, you take either n or m, but it will be overall like a m square m square n time complexity. So this is the brute force solution. You can find this code. I will share you with the GitHub link. So now let us try to solve using optimized solution using the O of n time complexity, and then also storage like space also like O of n. So yeah, base conditions are like length of s to 0 or length of t equal 0, return empty string only. And also same thing, we will take the t map that is equal to map of byte int. We need to make it okay. Now yeah, we need to see for equal to 0 I less than length of t I plus plus. We need to t map of t of I plus plus. Once done, then we'll take start and end equal to 0 0, and min start comma min length also could be 0, and math dot max int 32. Also we need to take few more variables. So we'll take the how many characters needed, that will be length of t map, how many are present inside this or different characters, and how many we have in the substring, that will take like substring will take that. And also we'll create one more map, for example window map, like a sub window, how many frequent sub characters present. So this also map of byte and int. Okay, now we'll try to see for end is less than length of s, we'll check the last character, I mean the position at the end position character, and then we'll try to increment the wind map character. This is the important condition. We'll see if count of tmap at ch is present, and the win map of the frequency of the same character is count. If this is the case, then we will try to increment the that character is present with the same frequency in that particular substring till now. Okay, and then if you see, if for have equal to needed, this is the same, then if n minus start plus 1 is less than minimum length, then we need to calculate same way. Min start equal to start, and min length equal to same n minus start plus 1. Okay, cool. Now it's done. Now we'll see the character at start equal to s of start, and character start, and win map of character at start. We will decrement now. This will remove from the window string, and still we'll check if count and tmap of th start. Okay, and window map of stat equal to count, probably less than count, then we need to decrement the minus, I mean have. Now increment the start plus plus for every case. Okay, okay. Now we need to increment the n plus plus here so that it will keep moving it. Again, the base conditions remain same. If minimum length equal to math dot max in 32, then return empty. Otherwise, same thing. Return s of min start in the start position of length min start plus min length. Let's run and see what happens. No errors. We'll see what is happening. Hmm. Okay, so this time complexity of this solution could be O of n only, because we are iterating once and we are just checking this one to for the sliding window basically. And space complexity could be like a O of n. Okay, I'm not sure the server, probably. Let us submit and see what happens. Okay, line number 13. Okay, 13. What is the problem? Undefined LEM. Okay, length. Okay, next undefined W map. Line number 33. W map. Okay. Okay, I think this is running now. Let us see. Yeah, this is the solution. This is the optimizer solution.